The y's and the r's?
You need to know x comma y.
But what if it's not a 30, 60, 90? Then you need to know it.
Yeah, how are you gonna know? How are you gonna know?
Gracie, give me a second here. After we go through a couple of these things, I'm going to show you why this is important in relation to the ordered pair for what we do with it next.
Oh.
So give me a couple minutes to get to that point, and then you'll start to understand again why I'm writing it as y over r versus x over r instead of opposite hypotenuse. There is method to why we do it this way. Okay. The other thing we talked about yesterday was your ordered pairs sets here. Remember, as you're going through these, in first quadrant, what do we know about both of them?
Positive.
Both positive. Second quadrant.
Negative positive.
Third.
Negative.
And fourth.
Positive negative.
Okay.
That's up.
Now, as you went through that, also remember what the x and the y was relating to as far as the ordered pairs were concerned. The x was in relation to which trig function? The x was your cosine, and y was your sine. So that meant, as you go through your quadrants, cosine is positive, sine is positive. What is tangent? Cosine is negative, sine is positive, tangent is? Cosine is negative, sine is negative, tangent is?
Positive.
And then positive, negative,
Negative.
and negative. So off of that, what about the inverses? Yeah, Lee. Tangent's positive in the 1 and 3.
Okay.
Because they have these, once they have the same sign, S-I-G-N, cosine or sine divided by sine, or sine divided by cosine, if they're both positive, you get positive divided by positive, positive. Negative divided by negative is also positive. That's why that one works. The inverses follow the exact same rules. The inverses don't change. So secant is going to be negative wherever cosine is negative. Cosecant will be negative wherever sine is negative. And then cotangent will be negative wherever tangent is negative. The other part of this stuff, as you were working through these, is that I was suggesting one of two ways to set these things up. Use your first quadrant ordered pairs set, or fall back to a right triangle. Because if you fall back to a right triangle, you know that opposite your 30 is what value?
1.
1. Yeah, the x, we said it was 1. Opposite 60 would have been?
3, 3.
And then 90?
2. 8,
Sorry. Been doing that all day. And then 45 was?
Root 1, 1, root 2. There we go.
And in case anybody was wondering, this is a freehand of an exact isosceles triangle. I measured it. I don't know, something to do with math. Now, when you're working with these values, I'm guessing that most of you guys probably did just fine working with degrees. Are there any of them in degrees you would like to double check as far as getting the reference angle and bouncing it around? Are we all right? Okay. Well then, let's just start working with the radians again. Because what we're going to do today is continue with these radian work. And I'm going to show you guys how all of this stuff can relate very, very easily within a right triangle, with special right triangle. Because everything we do that we wind up doing by hand has to be based off of a special right triangle in order for it to work. If it wasn't, if it was a sine of 40 degrees, you don't know how to do that. You would have to use the buttons on your calculator to make that work. So remember, when we're working on these things, what we want to do is get our setups. 11 pi over 6. What quadrant do you wind up in? It's almost 2 pi, right? How far off of is it from 2 pi?
1/6.
1/6. Okay. So pi over 6 is your reference angle. Right. So if your pi over 6 is your reference angle, that means it's a 30, 60, 90 triangle. Which angle relates to pi over 6? The 30 or the 60? 30. 30. One of the tricks that you'll find out here is that the 30 goes with the pi over 6, the 60 goes with the pi over 3. It's counterintuitive of what you want to think. It's just the opposite number. Okay.
Well, also you can think about unit circles and we do 3, 4, 6, 6, 4, 3.
Yeah, you can do it that way as well. So now if I'm looking at cotangent, cotangent is the inverse of tangent. Do you agree? If I drew the right triangle, do I need to worry about flipping anything around? What is the cotangent then? It's going to be what over what? In terms of opposites and adjacents. It's adjacent over opposite. So if I'm at 30 degrees, pi over 6, my adjacent is? My opposite is? So this is? Now the next question is it going to be a positive or a negative value? Why is it negative? It's in the fourth quadrant. Since only one of those values is negative, the sine value is negative, and the cosine value is positive because the x coordinate is positive, the y value is negative, that means your tangent and cotangent will be negative. It's very easy to bounce this out of a right triangle because you guys have all worked with special right triangles for a couple of years now. 9 pi over 4, what's the denominator? What's going to be the reference angle? It's going to have to be a pi over 4, so it's going to be a 45, 45, 90 triangle. Again, the only trick here is that I have to figure out which quadrant it's going to wind up in. 4 goes into 9 how many times? 2, and what's left over? 5 over 4. So if I spin it around, I'm first quadrant, aren't I?
Lucky.
My, what do you call it? My reference angle here is pi over 4. It works out rather nice. If I'm looking at the secant is the opposite of what function? Cosine. Cosine is adjacent over hypotenuse, but the secant would be hypotenuse over adjacent. What's your answer? Root 2. Okay. Works really nice when you use a triangle.
This kid Jack has an arm in his pocket. Must get beat up
Negative 5 pi over 6. Yeah.
So you want us to graph it and then you want us to draw it?
It will help you visualize it, yes. Because that way you don't have to go back and look at your chart. You'll be able to do all of these things by hand. And you'll notice it only takes a second to do it. Because you guys all know the ratios of your sides, it's very easy to work with. As long as you can build it out that way, there's going to be many different ways to do this. I'm also going to show you guys the way that they do this in pre-calc here in a little bit too. That way you get the idea of how really important this section is.
No, Mark.
Yeah.
On the reference angle, is it always you just drop out the numerator? What's it like? Always drop out the numerator out of the pi.
More often than not, yes. But you just got to figure out what quadrant you're in. So it's just, but yeah, that does work. Negative 5 pi over 6, is that a pi or not a pi? Not a tuber either.
Not even a full
What?
What?
Not full pi.
Yeah, it didn't even.
Has not. You ever saw it? Not. Kindergarten cop?
That's so inappropriate.
That was
Sorry,
very
inappropriate language, sorry. So, our reference angle here is pi over 6 again. My reference angle being pi over 6 means it's the 30. If I'm looking at the sine is the opposite over the hypotenuse. Sine of 30 degrees is 1/2. But is sine positive or negative in the third quadrant?
negative.
It's negative. So my answer to this would be
Negative.
negative 1/2. Yes, sir.
Can you do one problem with the degrees?
Yeah, we finish this one. I'll go back to agree with it. Just pick one out.
You
All
should
right.
do 47
Do
and
you
do
suggest
3.
pointless ways we draw out triangles?
Yeah, it's the easiest way to do it. It really is.
I think that's easier than that chart that we got. That's
What?
not easier.
One
Wait,
is the
what?
quiz.
Quiz,
I don't
what?
know.
Wait, what? We're having another quiz?
Eventually.
Well, like, isn't it pretty much just like
No,
two?
it's not in any near future, right?
I'll tell you when.
Do we have a test on this check, or is it just two quizzes?
5 pi over 3. Again, as I spin that around, it's a positive angle. What quadrant will I wind up in?
4.
I'm going to wind up in the fourth quadrant with a pi over 3 reference angle. Everybody okay with that?
Yeah.
So pi over 3 is the which angle? It's the 60. So again, that means this is a root 3, this is a 1 and a 2. Cosine works with the adjacent over the hypotenuse. So here it's going to be 1/2, but I have to think about it, is cosine positive or negative in the fourth quadrant?
Negative, positive.
Positive. So my answer is 1/2.
That every
I did
transform.
sign, darn it.
All right. Which one did you want to look at, Alex?
We should do
You
47
got number 49.
Okay.
and 40.
He like, I didn't have
780. 360.
You ready?
720. 780. How far off was that?
60.
60 degrees. So that means I'm using a 30, 60, 90. Secant is the inverse of what trigon? Cosine. If cosine would be 1/2, secant would be
2.
2.
47.
And it's positive because it's in the first quadrant. Does that make sense?
47. I just want to make sure I got this one.
240. Again, going the other direction. Here's 180.
Second.
And you're up again, how many degrees off of 180?
60.
60. Reference angle is 60. Cosecant is the inverse of sine. So the inverse of sine would be 2 over root 3. Do you agree?
Yes.
So if it's 2 over root 3, you're going to get 2 root 3 over 3. But is sine positive or negative in the second quadrant?
Positive.
Positive.
Positive. This is the y value.
When you say the but,
God. I knew I got some part of it wrong. Alright.
Okay?
negative 1. Oh, I got it wrong.
All right. Finish up with our trig one, or our radians.
Oh, I said negative.
What's that?
You meant to say I was sorry.
You gotta use the 3 on
Read, write, and arithmetic.
No, that's not even
Reduce,
R,
reuse,
right?
recycle.
Sine of negative 17 pi over 6. 6 goes into 17 how many times?
2 and
Twice
5,
with
6.
5.
2 and 5, 6. Okay?
So no matter.
So it's 1 revolution. And then 5, 6 brings me here, correct?
Yeah.
So you're doing 6.
Again, what is your reference
Pi
angle?
over 6.
I'm going to guess that you are correct. So if your reference angle is pi over 6, is that the 30 or the 60?
30.
It's the 30.
1/2.
Sine deals with opposites and hypotenuse.
Yes.
In this case here, it's going to be 1/2. But you are in third quadrant, so it's going to be
Negative.
very good. Negative 1/2. Alright. 23 pi over 6. How many times does 6 go into 23?
2, 6, 3,
3, and how many are left?
5.
Okay. So if I have 3 of them, 2, 3, 5, 6 brings me back here again, right?
Oh, pi over 6.
Again, what is your reference angle? Pi over 6. So pi over 6 is working with the 30. Secant is adjacent and hypotenuse, but it's going to be hypotenuse over adjacent. Man, you gave me scrunchy face. You okay? Sure? You're just nodding this fine.
I'm sure.
Okay. Okay, I just wanted to make sure. I just saw it for a second. I want to make sure you're all right here. Again, I'm working with secant, so I'm working with the hypotenuse and the adjacent, so it's going to be 2 over root 3, which is 2 root 3 over 3. But now I have to remember, is cosine and secant, are they both positive in the fourth quadrant, or are they both negative?
No.
They're both positive because it is to the right of 0.
So the answer positive. Yeah.
Yep, the answer is positive.
Heck yes.
3 goes into 17, how many times? 5.
And 2/3.
5 and 2/3. 2, 4, 5. 2/3 is back here. What's left? 60, it's 1/3. So your reference angle is pi over 3. So I'm working with my 60-degree angle. Secant works with hypotenuse and opposite, correct?
Yeah.
So again, my opposite, the 60 is root 3. My hypotenuse is 2. Therefore, the secant is going to be 2 root 3 over 3. Everybody okay with me rationalizing that right off top? Now, is it positive or negative?
Negative.
It's negative. Because sine is negative in the fourth quadrant, therefore cosecant is negative.
We're in the cosecant sign.
Okay? And then lastly, cotangent. Cotangent you should be able to do without,
Without a buck.
well, when you look at the denominator here, what's the reference angle going to be? Everybody agrees it's going to be 45 pi over 4 because the denominator is a 4.
Yeah.
When you're at pi over 4, what do you know about both the sine and the cosine values? They're the same, correct? So if I'm dealing with cotangent or if I'm dealing with tangent, if I'm dividing the same thing by itself, what's the answer always going to be? 1. It's always going to be 1. It's just a matter of, is it going to be a positive or a negative 1, which means all we have to do is just spin it around the axis to figure out where it goes. 4 goes into 13, what, 3 times?
3 and a 4th.
3 and a 4th. Negative, so we go here's 1, 2, 3,
Sit down on 4th.
and a 4th. So we are in the second quadrant. Therefore, the answer is negative 1. Okay?
Kind of looks like a snail here.
I just did them all.
Literally every time we're blue in
Yeah.
The idea that I wanted to make sure that you guys were getting this, and from what I've seen throughout the day today, more and more people are picking up on this without too much of a hassle. Am I correct in going on that off that assumption?
Yeah.
That's good. Now, what I want to do here is try to show you another trick that works really well with the quadrantals. A lot of you guys are having problems when we're dealing with stuff on the axes. So let's continue the discussion in the notes and stuff like that about how we work with the quadrantals again. So let's do this. What I want to do here is mark out 0, pi over 2, pi, and 3 pi over 2.
Are you collecting this?
No, I just did them all.
I didn't know if you were just going to collect it.
And what I'm going to start showing you guys is a little trick here that happens. As you're working through the stuff on the quadrantals, remember the ones on the quadrantals are the ones that wind up on the axis. So let's look at the ordered pairs. When I'm on the x-axis, what is my value for y? 0. Okay? So I know that my y value for both of these guys is 0. When I'm on the x-axis, what's my value for x?
0. X.
Which is it? X. And I don't know how far out this is, but I know it's going to be something x.
Or you explain or choose X, Y, and R, or explain R.
When I'm over at pi, isn't that negative x?
Yeah.
It's the same distance across. Now, when you're on the x-axis, what is your r always equal to?
X.
Is it equal to x when it's positive? Is it equal to x when it's negative? Or is it equal to negative x when it's negative?
Negative exponents. No. Wait,
It equals to X.
It's always x. It's always positive because how do you solve for r? You have to use what?
Square root.
Yeah, you're squaring. You're using Pythagorean theorem. Your hypotenuse would never be negative. The radius of a circle would never be negative. So you wind up, your r value is equal to x. Your r value is equal to x. Now, when I switch it to the y-axis, what becomes 0 in the ordered pairs?
X.
And what is the y value then?
Y. And negative 1.
Good. and then r is y. Would it change anything at all if I set x equal to 1 and y equal to 1? Let me show you an example.
Let's refresh.
If I set x is 1, does that change anything?
Yeah.
Locked into the definite place.
Well, if it was 7, would it change anything?
Well, the one position is one, then y has to be 0.
Yeah.
Okay, and then what would r have to be? 1.
Oh.
If x was 7, what would r have to be?
Yes.
7. So when you take the x divided by r, would you still get 1?
Yes.
Okay. Let's set x equal to 1. So what I want you to do real quick is just kind of erase. Set y equal to 1. So now over here at pi, instead of it being x, a negative x, what can I write? Negative 1. Here, I'm going to write. So that means that my r value, no matter what, is always going to equal, it's always going to equal 1. Everybody okay with that? If I let x equal 16, then r would have to be 16 because since x is on the x-axis, the r value is the same thing. All I'm doing is just shortcutting by calling it 1. I'm not changing anything. Let me show you something here with cosine. What's the cosine of 0 according to our ordered pairs? Remember how your ordered pairs go. Your ordered pairs, or first of all, let's do x and r. X and r, right, is cosine? What's the value of x according to my ordered pair? What's my value of r?
1.
What's 1 divided by 1? What's the cosine of 0? Okay. What was the x coordinate of the ordered pair on the quadrangle? So what's the x coordinate? Isn't that the cosine?
Yeah.
Remember that? Remember how your ordered pairs go? Your ordered pairs go cosine, sine. Your ordered pairs go cosine, sine as you were walking through them.
Sine is 0.
Sine of 0 is 0.
That's how much easier.
Another-
to out.
Same idea. If I write out sine of 0, that's y over r. Well, y is 0, r is 1. What's 0 divided by 1?
0.
0. What's the tangent? The tangent of 0.
Undefined.
It's y over x.
Oh.
0 over 1 is undefined, or is it 1 over 0?
It's 0.
0.
I said it
It would be
What happens here is that when you're on your quadrantal, use the ordered pair for which one you're at. The sine value, or excuse me, the cosine value is the x coordinate. The sine value is the y coordinate. Work your way around. It's very clean. Well, thanks for making it. The one reason that we do it this way, as opposed to a lot of times you see the x's and r's, but when we start to build it into this, you're going to see, well, let me ask you this question first. This is one revolution, correct? One full time around the circle. Goes from 0 to 2 pi. When you take a cycle of something, yes, sir?
the inverse of, alright, so what's CSC?
Cosecant.
So cosecant would be undefined,
Correct.
and cotangent would be defined.
Correct. Now, this is one revolution, correct? Goes from 0 to 2 pi. That is in a roundabout way of going around the circle. We do it that way. Well, what's going to happen is eventually we're going to go away from the circular of this and make it linear. If we make this linear, there's a starting point at 0. If I went one full revolution, what do you end at? you had 2 pi. Along the way, you hit 3 other spots, didn't you? You hit pi halfway through. You hit pi over 2 a quarter of the way there. And you hit 3 pi over 2 3/4 of the way. You guys with me on this?
Yeah.
Now, if I'm looking at cosine, when I started at 0, what was the ordered pair? What was the x-coordinate at cosine of 0? It was 1. So at 0, cosine was 1. The cosine, according to our ordered pair, at pi over 2 was what? What was the x value here at pi over 2? 0. What was the cosine value at pi? At 3 pi over 2. It's back to 0. And then when you get back to 2 pi, isn't that coterminal with 0?
Yeah.
What's happening is that we're going to be able to create the sines and the cosine waves off the unit circle. Everything is built off of going around linearly with the waves. Okay? This is where this is going to. This is where all these ordered pairs come from. This is how we're able to take a cosine wave, start at 0, work our way around, and a sine wave goes the other way. Yes? You don't have to, I don't want to overburden you guys with the actual curve yet. I wanted you guys to see why we are very, very specific within our ordered pairs to work within this specific period time to be able to do all these things. Yeah?
So what does tangent?
Tangent has an undefined area, doesn't it? Undefined spots? In a graph, if it's linear, what do you do when you have an undefined location? You have asymptotes, correct? Tangent does this. It's very simple to work. All right? Yes, sir.
Alright, so at pi over 2 and 3 pi over 2, x is 0, so then isn't r 0, so then what?
Oh, no. At pi over 2 and 3 pi over 2, the x value is equal to y.
Oh, crap.
Because you're on the
I forgot
y-axis.
about
Okay?
that. So then it's 0 over y technically. Alright, I got it.
Does that make sense?
Okay.
Again, the reason why I wanted to show you guys this is because as we build this stuff more and more and more, you're going to need to look at different ways of representing how these trig functions appear. And what I did here is I was talking with Mr. Thames, and Mr. Thames teaches this stuff in pre-calc, and he uses this chart. And I have this chart for you. And it is an extremely useful chart to help you work your way around a circle. Again, this is something you guys will see next year as a timed test. Seriously.
Is it going to be like at the beginning of the year we come in time test, like first thing, or is it going to be
No, when you get to trig,
we study it?
it's much easier than you guys believe. I'm not lying to you.
Oh.
I haven't, lied to you guys yet.
Isn't that what's where you test the first day of school?
Yeah, the very first day of school, you like told us a lie. I don't know what it
What
was.
about, it was something about time. Or slow.
It was
Oh,
something
yes,
about
it was the
slow.
slow
The reason why they use
M.
M.
It was the reason
Oh
why
yeah,
they
well that was just a fib. That wasn't a lie.
That was a lie.
Then it was a lie. You told us that you weren't gonna lie, and then you lied to us.
Hey. All right. What I want to show you guys here is how this works. Yeah, I'll get you a second. What happens here is, as of right now, do you guys agree that if you know sine and cosine of your basic angles, everything else falls into place?
Yeah.
If you know sine and cosine of all your basic angles, everything else falls into place. What I want you to do is I want you to fill in the 2 triangles on the upper right. Obviously, one of them's a 30-60, the other one's a 45. I'm sure you could probably guess which one's which. Okay. Ooh. Anywho, also, as we get over here to where it says degrees, let me show you how this gets filled in. The degrees you're going to be working with, we're going to start with 0, 30, 45, 60, 90, 180, 270, and 360. Boy, doesn't that get us all the way around the circle?
not in correct
Okay.
section.
Now, obviously I'm not worried about radians. You guys can fill in radians. Radians should be simple to work with by now. What I want, there is one other thing I want you to look at on your chart itself. When you're on your chart here, what I want you to do is replace where it says cosecant. I want you to interchange cosecant with cotangent. See how they go kind of out of order? How do you do this? It's magic.
I don't think we can do it.
You can't. What you want to do is just write this as cosecant and cotangent. Notice how everything we've always done in this class, we've gone sine, cosine, tangent, cosecant, secant, cotangent. This one just worked it backwards. It's not that big a deal. I didn't catch it before I ran it off, otherwise I would have done it. Now, everybody notice above sine, cosine, tangent, there are two smaller squares.
X, Y.
I want to put sine is y over r. What is another way you can write out sine? Very good. I want to write opposite and hypotenuse also.
Over H.
And I'm going to do that for my 6 functions. Because as I go through that with my 6 functions, I'm able to easily see where all my things are coming through. All right? Now, the other part of this is what's going to happen is eventually, not so much in this class, maybe, can't say that, I won't do this to you. I might give you this and a couple other parts here and there and give you 4 minutes and have to do it.
Is that possible?
We didn't do that till
Oh, it's close enough to pre-calc. It's in the same calendar here.
Is it June?
Yeah, exactly. Now, one of the things I want you guys to understand here is that if you know sine and cosine, everything else is just based off of that. It looks like there's a ton of stuff going on here, but isn't everything else just an inverse?
Really?
It really is. If you start working more and more with just the triangles themselves, as opposed to trying to memorize every single ordered pair going all the way around, you're going to beat yourself up doing that. You can build the unit circle off the right triangle like that with just using the specials. Now, the other thing I wanted to show you is that on the very bottom of this, there are three XY grids here. What I would do is I would write out my ordered pairs for my quadranticles on one of them, what we just did here with the 0, 90, 180, and all that stuff. And then I would also do the first quadrant in degrees, oops, and in radians for those 2 other ones. Oops, pi over 4, pi over 3. The reason why I want to do that is because that way I still remember the relationship if I do want to bounce things off around the axis itself, as opposed to trying to draw the right triangle. It's another way to represent it. Okay? Now, this isn't something I'm going to collect. This is a practice thing for you guys to kind of work through and to kind of get yourself an easier representation of how this works. I'm guessing that a lot of you are probably understanding more and more now. If we can build a triangle, it's a piece of cake. The possibilities are endless. Okay? So take a little bit of time to do this. I'll wander around and help you if there's any questions on that. I have 8 more problems for us to do tonight as far as trying to crank these out by hand. When you do these by hand tonight, I don't want you to look at your sheet. I want you to try and do that via the triangle that we've been working on. Okay? So start up on this, and I'll put up those 8 here in a second.
Wait, Tia.
What do you got?
What are we filling in here?
What are they? What's the
Oh,
radian?
okay.
What's the radian measure of 0?
That makes more sense. No, I got it.
I know she's.
What's the sign of 0? What's the sign of 0? What's the y coordinate at 0?
0. Oh, sorry.
What's the cosine of 0? What's the tangent?
Are you sure about that?
No, we
Wait,
just
no,
did
it's
this in
opposite.
our notes.
Wait. Oh, that's the opposite.
Oh, yeah,
You're messing us up, dude.
hi, good morning. I've been doing this all day, and can I make a mistake?
No.
I don't understand.
Wait, what? Yeah, what? Yeah, number. We have
What's that?
If there is zeros, how do you even have anything?
What do you mean?
Why is the 0 coming 1?
I don't know, it just,
Or no, 1 comes 0.
I mean,
For an ordered pair?
triangle with.
I mean,
Remember, when you're looking at the quadrant here,
I was
this,
thinking sine was x, but that's not.
yeah, this value here, oops,
It's always.
this value here is 1. This value up here is 1. This value here is 1. This value here is 1 because this is the radius of the circle. If the radius is 1 or if the radius is 73, it doesn't matter because it's always going to simplify itself out to equal 1, or it's going to be 0, or in tangent's case, it could be undefined. That's all this is meaning. Okay? That's all that means when you're looking at these ordered pairs. As you're coming up the circle then, you've got your root 2 over 2. Now these, remember, are formed off of the right triangles. This one here is formed off the right triangle. Okay? It's just basing itself back over and over and over off
Is
of
this
those.
all of our homework? Is this chart thingy?
Yeah, and like I said, I've got 8 more of these problems for you guys to look at then as well.
So
Okay.
can you just do that?
Yeah, I've got to find out. I forget what page it was on. But on the website, I'm pretty sure I put that as the extra practice problems part.